Hi, it's Mahmoud again, and let's start with creating the geometry as our first tutorial here. And before going with answers and creating the geometry, let me quickly go over the geometry parameters. So this is geometry, the one we used in our latest work for continual learning. You can check the paper with this title here. Our geometry is idealized aneurysm, and it consists of two parts. First one is an idealized artery parameterized by the curvature radius and the artery diameter. And also we have an idealized aneurysm. It's idealized using the neck width and the aneurysm width. Now let's move to Ansys. As most of you already know, this is the Ansys workbench interface. We'll start by dragging the geometry interface, or you can just double click on it here. Now inside Ansys, there is multiple CAD modeler that you can use. By left click here, you can check which one is already the default. The one we will be using today is SpaceClaim. You can always keep an eye on the status of Workbench from this bottom left part. Now this is the geo for the SpaceClaim. How we will be tackling this problem? Basically, we will be reconstructing an initial geometry inside this geo and using the Python script or tracking script inside SpaceClaim. For each command or each move we'll do here, it will be recorded inside the script here at the right. Two things you need to make sure before going further in this work: that this red button for recording is already activated. Second thing is the API. Just keep an eye on this one, because sometimes if you generated your geometry here and then you need to mesh it inside Ansys meshing, due to some conflict between these versions, you may be facing some problem with the name selections or boundary conditions naming. So the way to solve that is basically to play with this interface or like versions. Now let's start. First thing we will be creating is our artery. So let's select a new sketch plan. Selecting the new sketch plane will make the view perpendicular. Now we need to have a set dimension for the artery length from the inlet to the outlet. And one advice here, basically try to like reduce the constraint that you are doing, because not every constraint is reproducible inside Ansys SpaceClaim. And I'm gonna show you later what I mean by that. So basically just any dummy line here. Now I need to set dimension for this one. Choose dimensions and change the dimension. Let's make it 50, for example. Now I need this to be symmetric around this y-axis. Let's pick the symmetry constraint, choosing our symmetry axis, first point and second one. Now you can see here, this is the dimension that we used. So this is the first variable we can parameterize. We can call this one artery length 1. Let's make it 60, for example. Now I'm gonna do this only once, but during creating a new geometry, for example, you will need like to do this multiple times or after each step to make sure it's reproducible. So I'm gonna delete whatever I did here. So basically this script should be able to make the line that I made the symmetry constraint for it, and then deleting it. Press this green button or play button here. You can see it's already created and deleted. That means like this is safe to be parameterized. So I'm gonna delete this, delete object command again. and create this one. Now I have this artery length. Next step, I'll be doing just a circle. This circle will be controlling the curvature radius. Again, like just any random circle. I'm gonna assign dimension for it. Let's say 130 millimeter as diameter. Assume I wanna my um, I need my radius to be 70, so diameter will be 140. Now I'm gonna do two constraints. One thing like worth mentioning here, some of you maybe say this is not the most straightforward way to do it. I totally agree with you, but again, not every constraint is reproducible here, or it may be failed if you tried just running it from the script. So you need to keep like iterating and trying different method, whatever is working. So this one worked with me. So making coincident constraint here, and again at the other point, and as you can see, we have this like this will be representing our artery here from this point at this point. Now next we will be removing the parts that we don't need. So double escape here. We can make this one as construction, and we need to do some trimming here. So I'm gonna add a line at y-axis, and then I'll choose trim, yeah, trim away this one, and this one as well, and this one, and I can make this one for construction as well. Great. Now next I need to make the artery itself, the diameter of it. So first thing is to change the plane. I'm gonna go for YZ plane this time. Sorry, the interface is not very smooth. Yeah, YZ. Okay. Now I need to plot a circle here over this point. This one will be representing the artery diameter. Let's set dimensions for it. Let's make it 4, for example. And as you can see, it's recorded the radius now. So if I wanted to parameterize this one, I'm gonna go at the top, mention artery diameter equals say 4, and here I wanted to make it artery diameter over 2 because it's the radius now. Next step, I need to do revolve, I think, like pulling over this or sweep. Yeah, sorry, it's sweep. So first I need to choose the profile, which is this circular one. I need to choose both of them. Okay, and then sweep over this line. Yes. Next step, I need to mirror this one into the other side. So I'll choose mirror. First, I need to choose the mirror plane, choosing the geometry. And here we totally created our artery. Nice. If you wanna, you can save the work by now. Next, we'll be creating our aneurysm. So let's a new sketch, and again, we'll need to go to the XY. Okay, let's go perpendicular to it. Now, if we wanted to parameterize the neck, if I have my aneurysm starting from the far top of the artery, so basically the neck would be as small as possible. If it's starting from here, it would be like the biggest as possible. But again, this is not very accurate. We have like a formula that we used inside our original script that would be attached inside the, or like at the, in the description of the video. So I'm gonna do it like in a simpler way now, but later you have like the script, and inside it we have the formula that were used to reconstruct the neck. Now we'll have the line. This line will determine the start of the aneurysm. Again, just make it like horizontal line with any length, and then I need to make the aneurysm itself. So aneurysm is just like a sphere. So this line will be representing the radius of it, the second line, and its length is 3 millimeter, I think. It's yeah. Now I can just make a circle here. Next is do revolve, and again you can just add a variable for this 3 millimeter and parameterize the aneurysm width using it. Bond. You can choose only half of it. It will work, and then revolve. Choose this line, for example, and just we need to rotate. Yeah, I'm just like using Ansys over a virtual machine, so sorry, it's not very smooth. Yeah, I think we did something wrong here. I think this should be add. Yeah, make sure to select add from here. Now rotating over this one, we can just make it 360, and that's it. Now, a few advices here. Basically, if you did multiple selections, so if every selection or every move we are doing here is being recorded. So if you did a move and it was recorded here, make sure to remove it, because doing a move and then trying to reproduce the geometry mostly will result in a fail. Last two steps basically is creating named selections for inlet and outlets and whatever selections you need to name. Second thing is saving your file. So to do name selections, we will rename this one as our inlet. We need to choose the face. Selections, sorry, groups here, and then you have create NS, which is named selections. Let's call this one inlet. Second one is the outlet. Let's choose it. Create name selections, outlet. And then we need to save it. So save as. Now for the extensions, you have like multiple extensions. You have step, for example. You have STL, but for meshing, we usually prefer step. And you have that new extension, which is Fluent Database FMD. This one will be working with this one. So just choose it, the name of the file, which is record, for example. Now you can see you did your name selections, you saved your file. And if you are like doing multiple files, you will need to have a variable here, which is like naming each file differently. One last step to do during producing multiple files, you will need to delete each file after creating it. So the way to do it is basically You will come here to the structure again, select all of them, right click and delete. You have this command now which deletes everything. Now we will be attaching the final script that we use with the dimensions and parameters that will create the 40 geometries we used during our paper mentioned at the first of the video. Thank you for the following and see you in the next tutorial for the machine.